All right, to start out Unit 4, we're going to take a quick look at polynomials and what they are and how we can classify them. So in general, a polynomial is a monomial or sum of monomials. Now, what's a monomial? A monomial is a one-term statement. It's a one-term sequence of numbers and letters. So we have one term for a monomial. And you might expect a binomial has two terms. Trinomial would have three terms. And anything higher than that, we just call a polynomial. So four or more terms. Now, a term is a number with or without variables. These are the things that are added together, separated by addition in a polynomial. Okay, so one thing we can do with these is find the degree of a polynomial. And if we just have a monomial, or each term of a polynomial can also have a degree, we just add up all of the value of all of its variables, the value of the exponents. So we add up all the exponents here. For example, in the monomial, the single term polynomial, 3x to the fourth, y to the third, z, we can add up all the exponents and find the degree. So the degree here is 4 plus 3 plus 1, which is 8. Has a degree of 8. 4 plus 3 plus 1. Now, the degree of a polynomial, if there's more than one term, so the sum of, more than one monomial, the sum of monomials, is the greatest degree of any one term in the polynomial. So to find the degree of a polynomial, we have to figure out what the degree of each term is. And the highest one is the degree of the polynomial altogether. So in this example, 4x cubed plus 2x squared minus x plus 8, the degree here is 3. The degree of this term is 2 when we have 1, and this actually is degree 0 for the constant. So this polynomial has a degree of 3 because the highest degree term is 3. Now, a number or term without a variable is called a constant. It has a degree of 0, as we just mentioned. So let's practice this. Let's name each polynomial based on the number of terms and then find the degree of each polynomial. Well, example A, we have one term, so it is a monomial. And it has a degree of 1 plus 2 is 3 plus 3 is 6. So its degree is 6. Example B, we have a trinomial. It has 3 terms, 3 monomials separated by addition, and it has a degree of 2. That is the highest degree of any one term in the trinomial. And for example C, we have a binomial here, and it has a degree, well, this term here is 3, and this term here is 0, so the degree here would be 3. Now, polynomials do have a standard form, and that is to arrange the terms by degree. The highest degree terms should go first. And so one thing to keep in mind, just a vocab term here, is the leading coefficient. It's the number in front of or multiplying the first term. So just the very first number when it's in standard form. So for these examples, we'll arrange each polynomial in standard form, and then identify the degree, leading coefficient, and the constant term. So for example A, well, the highest term here by degree is 8x to the fourth, and then the 3x cubed, and then the 2x, and then the negative 11. So here's our standard form there. The degree of this polynomial is 4. The leading coefficient is 8. It's that first coefficient on the first term. And the constant is negative 11. That's that last number without a variable there. Let's try the next one. Now we should combine like terms here. X to the fourth minus 9x to the fourth. We can combine those because they have the same degree. So we get negative 8x to the fourth plus 7x squared minus 2x. So this has a degree of 4 again. Its leading coefficient is negative 8, and it does not have a constant term because we have an x on our last term there. Okay, let's go to example C. Looks like the highest term by degree here is negative 2x to the fifth. Then we've got plus 5x to the fourth. You can help to cross these out as you use them. Plus 8x to the third. It is positive, so we write plus. And then plus x. So again, the degree here is 5. The leading coefficient is negative 2. It's that first coefficient there. And again, we don't have a constant term. Let's go to example D. Looks like the highest term here is 3x to the third plus 7x squared minus 4x plus 5. The degree here is 3. The leading coefficient is also 3. And the constant is 5. Example E, pretty short one. Here we just want to put 3x to the sixth first because it has a higher degree than the 1, obviously. The degree here is 6 for the polynomial. The leading coefficient is 3, and the constant is a 1. And the last one, 6x to the fifth plus 4x squared plus 3x plus 2. So our degree is 5, our leading coefficient is 6, and the constant is 2. Now this might seem pretty simple, but it's a good habit to get into, always writing a polynomial or an equation in standard form with the highest degree terms first, because whenever you're going to use polynomials to do any sort of operations or work with them, you're always going to want them to be in standard form so you can more accurately line them up and make sure that like terms get combined together correctly. So it's a great habit to get into, and this is good practice on that. So highest degree term first, and then down from there.